Hey everyone, welcome to the very first video in a series I'm calling Hacker Toolbox. In this series, we're going to be looking at some of the most common tools used in bug bounty and really talk about how a beginner can use them. So we're not going to be focusing on like really in-depth stuff. I'm really going to show you how you can use some tools to solve really common bug bounty problems. And this week we're covering ffuf. Now ffuf is a fuzzing tool. It's used a ton for brute forcing, directory searching, but it can actually do so much more and it's so powerful. So what I really wanted to show is some one-liners that you can get started. You know, this line of code solves this particular problem. And that's the kind of aim of this entire series. But first off, this video is sponsored very kindly by Integrity. Integrity is a bug bounty platform like HackerOne and BugCrowd. It's smaller and focusing on European customers. They're huge supporters of the bug bounty community, sponsoring not just my content, but other creators too. And I'm actually really happy to work with them. I know a lot of people have already signed up, and people have even found their first bugs or participated in the XSS challenges. Some people have even gotten bounties, and I'm really happy for you all. So if you want to sign up as well, you can use my link on screen or in the video description. That's go.integrity.com/Katie. Description on screen now. You can take a look. But let's get on. So what is ffuf? Now this is ffuf, or ffuf in a nutshell. What is it? It's a brute forcing / fuzzing tool. You send it a word list, you send it an endpoint, or a URL, and it will just go through every single possible combination of, like, on that word list. Very, very simple. It's not a very complex tool. It's like Burp Intruder, but it's very, very, very quick. Quicker than Burp Intruder is, especially if you don't want to pay for it. What does it output? It outputs both JSON and CSV data. So if you want to pipe it into other tools, you can create kind of translations. If you're not very confident with that, you can just send it all to Burp directly and then let it kind of show you what works and what doesn't work. And that's primarily how I'm going to show you how it interacts with Burp directly. I have created a tool on my website, and I'll link that down below, which you can just paste in the JSON to just give you a list to make it a little bit easier. So why is ffuf so popular in the bug bounty community? It's quick. It is so quick. It can test so many word lists, so many endpoints all at once. And really, that's such a huge advantage for doing fuzzing very quickly. I'm really only going to show you the basics, but there's so much more on top of this. Like, you can just look at the documentation for ffuf and see just how much more it can do. So what is the kind of limitations of it? It's difficult to do complex brute forcing, especially when you start to have multiple parameters or you need to have cookies and stuff like that. It's totally possible. I'll show you how. However, that is something to consider if you're kind of maybe a bit newer, maybe focus on using ffuf to solve simpler problems. And what does it replace? Well, Burp Intruder, directory search, dir search, or, you know, you can even replace something like Argent for parameter mining. So let's take a step back here. Why do we actually brute force in bug bounty? What are we trying to do when we use tools like this? So the first thing we're trying to do is content discovery. We're trying to find new things to hack. We might also try and find new parameters. We might be looking for new files. We might be looking for new API endpoints. Primarily, we're trying to figure out our attack surface. If you check out my video on API enumeration, you can see, and actually my introduction to recon video, don't worry, there's more coming, I promise. You can see primarily when we do kind of recon activities, what we're trying to do is map out that attack surface and see what's there. And there's quite a lot of bugs that use this as kind of a first step. Information disclosure is a big one, you know, finding those URLs which actually tell you way more than they have to, finding admin panels, that kind of thing. And a bug called mass assignment. Now, if you want to learn more about that, you can look at my top 10 API bugs video. And actually, all of this is really common for API bug hunting. APIs are some of the best things that you can fuzz because they have like parameters that you have to guess. They have endpoints you have to guess. You really have to do quite a lot of guessing. So something like ffuf made that process so much easier. So if you haven't already got it, you can download it on GitHub. I'll put a link to the releases page. You can see a direct link to download it. My favourite thing to do is then to add that to your path. You'll have to look up how to do it. I'll leave a little link about on how to do it on Mac and Windows. But that basically means you can use it at the command line with ffuf command rather than going file, download /ffuf/ffuf command. That's what you'll see me doing. So there's information about how to set that up in the description. Now, word list. Now, whenever we do any kind of brute forcing, having a good word list is really important. Now, there's two different types of word lists, really. One is ones that are available online, and the other ones are ones you create yourself. Tom Nom Nom's talk on word lists from NahamCon is so good. I was so inspired by this talk. It was amazing. It was incredible. Really recommend it, especially if you're working on a target which has maybe quite a large scope, but actually you really want to test for things like discovery that might be like a little bit more kind of specific to a target. And then seclist is great because you have quite a lot of standard options. Payload all the things is great because you've got a lot of payloads you can just try, especially if you're testing something like XSS. You maybe can't be bothered, you'll send a bunch of payloads and see what ffuf deals with it and see what comes out. And these are two great places to find word lists. Right, let's get into it, the technical bits, the basic usage of ffuf. So I want to start really with talking about the very, very basics of how to use it, and then we'll talk about some advanced stuff. I'm not going to be showing any demos because, quite frankly, it would be very boring. Because it would be like, here's the command and here's the output, and I've already turned it into slides, so we're fine. All of these commands will be available in the description below, written out so you can copy and paste it and try them out for yourself. So, this is the basic usage of ffuf. Now, if I just get my little pen out here, this part here is the command. So that's telling them what program you're running it in. This part here in blue is the word list you want to use. Now you have to use this flag here that says W, and then this is the file word list you want to use. Now your word list might be in one directory, another directory, and then it might be whatever.txt. Sorry, I'm typing with a trackpad here. I'm writing with a trackpad. Whatever.txt. Now we have the U flag, which is the URL you want to fuzz. Now this is the URL here, and this won't work on your machine because this is a website that I set up to test it. You'll see the keyword fuzz. Whenever you want to fuzz something in ffuf, you use this keyword fuzz, and wherever that ends up being is what gets fuzzed. You then have where you want to output it. So here we're outputting it to a text file called output.txt. By default, that's in JSON. So if you're not necessarily familiar with JSON, you can change the output, check the documentation. And then this is the really important part here, replay proxy. Now what replay proxy does is allow us to replay the ones that match kind of are 200, so have worked, or ones that are no permissions, 302s, or redirects have all gone to. And then that is our burp proxy. So what does that mean? That means any working request has gone to burp. The work requests that don't work don't go to burp. If you use the free version of burp, this lets you have the power of ffuf while also putting everything into burp so you can easily deal with it, like so. So here we have all the URLs that worked. So these are all things that exist, and they're just sent by ffuf directly. So a really great way to deal with the output if you're not confident with ffuf. If you're just kind of, I don't really understand, I'm not really sure, this will have all of the working ones and put it into burp. Replay proxy is so useful. You also have the command X as well. And what X will do is send every request through the proxy. If you use the free version of burp, your proxy is essentially going to be limited. So if you use X and every request gets sent, let's say you've got 2,000 requests, 2,000 requests will go through burp at the slower speed. If you use replay proxy instead, and you have 2,000 requests but only 200 work, only the 200 that work go through burp. Just makes it easier to deal with. So then you have the output in JSON. Now, if you're not confident with JSON, don't worry. I've actually got a video that I'm working on right now that's going to talk about how to interpret it. The important thing to look at here is we have the command line argument we run. Very useful if you want to recall results, and what time it was run, less useful. Then we have this array, and we can tell it's an array because it uses this thing here. That means array, so a list. And this one here, the curly brace, equals object. So here we can see in this first object, we have the input. So fuzz was applied to users. So this was what we were fuzzing. So this part here, where we look at the URL, fuzz gets replaced with whatever's in here. So in this case, users. And we have some information about the length and the status, the words and the lines. This is really useful. We'll see later on. And then we have the URL, right? And the status as well. So that tells us 200, it worked. So that's really useful to know. And then here, this tells us the URL that worked. If you prefer to work outside of burp, this is what worked, essentially. So this is what you need to investigate further. Now, one problem you might have is that actually we need to be logged in to see a resource. And that's really simple. You can use the B flag here. This flag here will allow you to put in whatever cookie as long as it's between these strings here. Now, the grey thing here is what we haven't changed from the previous command. So we do the previous command, we just add that cookie in there. And that's really useful if you need to be logged on. And we can actually put in any header we want. And we'll see that in a second, but this basically allows us to start fuzzing for, stuff you need to be logged in for. This is really useful for API endpoints. You might need to be logged in to be able to access them. Very, very useful. And the difference here, as we can see, in the headers when we run it, we've got our cookie Laravel session, which is just the session token that Laravel stores. And in here we have nothing. So we can see that these results here have got a 302 error. We can't access them due to security reasons. We don't have permission to access them. But if we have the cookie, we can see they're now 200. Now, a 302 might be applied to an entire directory. So a 302 error may not actually tell you what you want to see. But in fact, this might then say, okay, actually, you know what, users, classes, and grades does exist, and here's where it is. Really, really useful for dealing with web applications where you're dealing with cookies, dealing with bearer tokens as well, just to make sure they get passed around and you're actually fuzzing for the right stuff. And then we've got fuzzing headers. Now, this is really cool. I didn't know this until I started making this video. One of the cool things you can do is you can move the keyword fuzz to different parts of the output. So here, right, here we can fuzz the user header. We can change our fuzz from here, which is users, and instead put it in our user agent. Now, if you want to experiment with X-forwarded headers and stuff like that, this is a really cool way to do it, because you can test for a bunch of different headers that might give you further access. And in terms of output here and what it looks like, we can see here that our user agent has changed to students, to classes, and we can put in any header there and it will work. We can even put in host. It doesn't work, but if you want to experiment with it, you totally can. Any header, you can put the fuzz command keyword anywhere, and it's so powerful. I didn't even know that. It's amazing. It's incredible. I can't believe I didn't know. So then that's kind of some basic usage of it. A lot of bug bounty programs will ask you to limit the number of requests. Now, ffuf is very, very, very fast, which is amazing. It's incredible. It's brilliant. But if you're limited to 100 requests a second, you're going to get hit like WAF. You're going to hit your web application firewall. You might hit Cloudflare. you might hit a bunch of different things because you're sending requests too quickly. Now you can also add a delay with ffuf. So you can use P, which reduces the seconds between requests, and T, which reduces the number of threads. So when a computer has threads, it means it's kind of starting up little mini versions of a service. So here it will, each one of these little dots will send its own request to the website, which, as you can imagine, although you're on one computer, you've got all these little drones that you connect to, which are sending requests on your behalf. So if we control the number of threads, we can control the little number of workers, and if we can control the seconds between requests, we can start to tweak and see how long it takes to run stuff. So here's the difference. So the difference we can see in here. So we've got timeout and threads over here, and we can see timeout and threads over, delay and threads, my bad. And we can see that the default one has 40 threads. So regardless of what you set the number of requests a second to, you've still got 40 of them sending that many requests a second. So the best way to do it is to use the combination of these and see how long it takes. So here you can see this command took 12 requests a second, and this one I got it down to 1 request a second. So that's really useful when you're dealing with something where you're hitting a bunch of times. Although 12 requests a second may not be a big deal, 100 tends to be where most places are. It can be really important when you're dealing with very, very large word lists. But actually, as I was making this video, a new beta feature is being released. So it's still in testing, but if you're watching from the future, there's been a new feature that allows for rate limiting to be done much easier by using the rate and then number to X. It will limit it to that many requests a second. So if you do rate 100, it limits it to 100 requests a second. If you want to test it right now, you can use this command here. If you have Go installed, that will grab the ffuf, the most recent one. It's not been released yet, but it is in the future. It will be in the future. And so this is how it changes it. We have rate 100, that will limit it to 100 requests a second. Done. That's it. That's all you need to worry about to add a delay. And how cool is that? That's incredible. It's going to be so easy to fuzz things now. So fuzzing two values, another common one. So this is our command again, and we can see we've got our wordlist.txt, but actually now we have fuzz, and now we have me. Now what we can do here is use two word lists, or the same word list, to fuzz two values. Look at this. You can put fuzz here and me here, and that will come from that word list, and that will come from that word list. And you can even do it using not just multiple word lists, but also then grabbing kind of the same word list. Maybe you need a list of numbers, and the other one you need like a list of actions. It's so cool, and I really want to show this off. The other thing is you can swap between cluster bomb and pitchfork. Now, if you don't know what the difference is, this is the difference. So where a word list, if you got a word list like this, which has list 1, ABC, list 2, 1, 2, 3, cluster bomb will do every value. So it will do A1, A2, A3, B1, etc. Pitchfork will do them kind of as they are in the list. So it will only do A to 1, it will only do B to 2, it will only do C to 3. And this can be really useful when you're messing around with, say, API endpoints where you want to test stuff a little bit differently. Maybe you want to look at numbers, maybe you've got something in mind. So what does it look like in output? Well, we can see here that where me is verify and users is fuzz, we've got a 200, but a size of 0, so it's probably not a legitimate one. And this is kind of what it looks like when it runs, and then we can see the results here. We've got 380 results. Now, that size is 0 and that words is 1. Did that really work? We have 380 results. They all return a 200 status, but the length is 0. That likely means it didn't actually work. There's nothing that happened. So what can we do about it? Let's go do some cool stuff from this, okay? Now, filters and matches. Not all websites will like return appropriate requests, like a 200 error or a 404. Sometimes they'll accept anything and just give an empty response. So some of the really cool things you can do with ffuf is have filters and matches. Both of them help kind of cut down your 380 results into the 5 results you're actually interested in. So a filter will remove request response which match the filter. A matcher removes requests and responses that do not match the matcher. That's really important to know because they're different. If you know what you want to remove, use a filter. If you know what you want to keep, use a matcher. So if you have a default error page that you know is 1,000 characters, use filter. If you have a say a 302 error, you specifically want to see the ones you're not allowed to see, you want a matcher. So they're slightly different, but it's really important to know the difference. Now here's some of the cool things it can do. I'm not going to show everything. It can match response code, lines in a response, regex, so it can do pattern matching, the response size, the amount of words in a response. And it's the same for filters, so they're basically, you can replace a F with a C and an F with an M and it will still work. It's very cool. And this is a very simple filter. So what I've done here is filter it so we're removing all of the words that have all of the responses that have only one word. Okay? And we can reduce our 380 positives because they had only one word to 2. So we can see here what we've got is admin delete and admin restore. So the 2 endpoints that are the most interesting, that are worth further investigating, can be very quickly filtered out. And another option here is using the matcher for a 302 error. We're only interested in our 302 redirects because that means that we haven't got permission to view something, because it will redirect us to the home screen. And if we know that, we can see the same, right? We're still seeing, because they're both 302 statuses, that has limited our 380 results to just 2 again. So our admin delete and admin restore, the ones worth looking into. You know, that might tell us, okay, so there's an admin panel, I want to gain access to that, and here's some of the endpoints I can look for. But sometimes these filters aren't enough. 200 status codes do not indicate that something has worked, especially with some error messages. The length might not be consistent to match on. So here's an example. We can see that users to 203,432 has worked, but actually when we look at it in burp, we can see we're actually getting a kind of not found error here. So it's worked, we know the status, we can see it's got a length, we know it's got words, it's got lines. According to our other matches, this would work and be successful. But actually when we look at it, it hasn't. Now here's really cool. We know what the response is here. We know it says not found true. We can use the regex one to just filter out any results that contain the text not found. Turning again our 380 results, or our 24 results with this one, down to 3, the one that actually works. This is so cool for dealing with false positives and really making sure that when you're doing fuzzing, you're fuzzing for the right stuff at the right time. Very, very awesome. Okay. Dealing with form data and get and post. Now, ffuf can fuzz more than just directories. And this, I didn't know most of this. I will be honest and say I looked into this. I was going to make a video. I looked into this and thought, whoa, really? Because I just didn't know. And it is so cool. So let's say you've got a form, like a login form. You can actually fuzz post data by, again, just using that keyword fuzz. So D here refers to the fact that this is post data. We can see the input here is an email address and then some random text. But by putting the fuzz thing there, we can then add that form data in, like so. You can see information is being changed to user, to users. whatever we want to do, we can see that this is being fuzzed. And some really cool uses for this might be to test default passwords, to test email addresses, to test, big XSS payloads. You've got a list of 30, you just want to say, well, just throw everything in there. Very, very useful for just sending those forms. But you know what else you can do? You can fuzz parameters. So not just we're fuzzing the data inside. Oh, no, we're fuzzing the parameters. If you can't get Argon to work, this is a great alternative to start testing parameters as well. Because you can fuzz parameters. What you could do is you could set each of these to be a separate word list. You can use a parameter word list. You can fuzz all of this with the same word list. And bam, you've got the functionality that Argon does with ffuf, and it's amazing. And you can see the output here. We've got grade here, and we've got students here instead of information like it was before. And this is great for testing like form data, testing for those mass assignment bugs. If we have a list of like every API endpoint we've hit, or every parameter we've hit in the API, we can do it like this, and it's so cool. Right, okay. I'll stop nerding out over this. This was really exciting to me. And we can do the same with get as well. Again, you can see we've got fuzz in the parameter. And we can use a filter to help deal with false positives as well. So the output of that is we then have this here, which is very, very cool. And you can see we can fuzz not just post, but also get. We can fuzz parameters, not just data. And you know what else we can do? We can fuzz JSON post data as well. We can use, here we're using the HTTP verb put because we're trying to edit something. We can add a header, which is a content type application /JSON. And in our post data, we can have JSON. And you know what? We can fuzz the parameters for JSON as well. Just by moving that fuzz word, we can change so much in our requests, and this really does up that functionality from being kind of, oh, this just finds directory endpoints, to actually being able to do quite a lot. Now you can see here we've got a students as being called, and we can see that it's made a bunch of requests here. So really, 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 really cool. I can't stress how amazed I was about this. Maybe I should be reading the documentation more often, but this was so cool to me. I was so excited by this. This is going to seriously up my game as well. Like, I'm already starting to sort out some of my word lists and really get a good methodology going. So I hope you found that super interesting, super useful. Maybe that impacts your practice. It certainly impacted mine. I'm being honest when I say I legitimately did not know about this before I started doing the research for this video. And oh my god, I have actually fallen in love with ffuf, and I might marry it. I don't know. So thank you very much for watching. And thank you again to our sponsor Integrity for sponsoring my content. I really don't take having an advertiser lightly on my channel, and I really do think that they do amazing things for this community. It's really allowed me to make serious investments into my channel, like improving the audio and the editing. They really interact with their community and are always replying to hackers, sending out swag, and really being an awesome platform. So do give them a lot of love. You can sign up with my link on screen. Again, it's go.integrity.com/Katie. It's all in the video description. Thank you very much for watching, and let me know if you liked this video, if you liked hearing me nerd out about a tool that I just found so much about. Super exciting. I hope that everyone is doing super well. Let me know what some of the tools you'd like me to cover might be. Is there a tool that you're like, I just don't get it, I don't understand, I need it to be simplified, that you think you want to watch? Let me know. Let me know in a comment, let me know on Twitter. Thank you very much for watching, everybody. I will see you all next time. Bye, everybody.